This video is going to review piecewise functions. Piecewise functions were in Chapter 2, and they usually, for most students, are one of the newer things in Chapter 2 that they need a little extra practice with. So we're going to go through and talk about how you evaluate a piecewise function, how you graph a piecewise function that has two equations, and then we'll finish with how do you graph a piecewise function that's made up of three equations, which is the most that you would see on a test or quiz. So when you're looking up here, we have a piecewise function. What makes a piecewise function special is it's made up of more than one function, but we decide which function to use based on the x values. These pieces right here, if you look here and here, those are called the constraints. They tell us, depending on the x value, which equation you should use. So if you look at the x less than or equal to 2, what that's meaning is if you're picking an x value that is 2 or smaller, you're going to put it into the top equation. If you're using an x value that's bigger than 2, you're going to put it in the bottom equation. So you have a decision to make. You have to take the argument, the number you're plugging for x, and decide where it goes. You'll never be putting it into both. So the first thing that I'm asking you to do is find f of negative 1. So negative 1, when you're making your decision, you're seeing that negative 1 is less than 2. So that means you're putting the negative 1 into the top equation. You can do this by hand. You can do this using your calculator, just plugging it in, or you can use this using the table function of your calculator. So I'm just going to do it by hand. We have negative 2 times negative 1 plus 1, which is positive 2 plus 1, which is 3. Your answer is just a number. It represents the y value. If you wanted to write it as a point, you would write it as negative 1 comma 3. The next one wants f of 2. 2 is going to also go into the top function because this is where it is equal to 2. It can never go into both, so even though both of them are kind of happening around 2, the top one is where we are including 2. So we're going to take negative 2 times 2 plus 1. That's negative 4 plus 1, which is negative 3. Again, your answer is your y value. And then finally, f of 8. 8 is bigger than 2, so we are going to use the bottom line. We're going to plug it in for x in the bottom line. You have half of 8, which is 4. So that's the first thing you're going to be asked to do on a test setting, is to take a piecewise function, or you could have multiple piecewise functions where you have to make a couple decisions and decide what you get when you are evaluating, decide where you put the argument. The next thing they're going to be asked to do is you're going to be asked to graph piecewise functions. When you're asked to graph piecewise functions, I think the best thing to do is to set up coordinates that go with each piece. What you're going to have when you draw these is you're going to have two rays. One is going to be heading left and one is going to be heading right. And you have to decide where does the ray originate or start, and then what direction does the ray go from there. So I'm going to rewrite the piecewise over here so I have a little more space to work and walk you through this. So when I go to graph this, I think the best way to start these problems is to take that changing point, this 2, that is the number where it's switching from the top equation to the bottom equation, and plug it into both equations. It's not going to be present, it's not going to be a filled-in circle at both, it's only in the top, but it tells you where one stops and the other one starts. So if you plug 2 into the top equation, we actually already did it up above, you get negative 3. You just did it right here, so you can save yourself a little bit of time. If you plug 2 into the bottom equation, you haven't done this yet because this is not actually a point on the graph. It's going to be an open circle, but it tells you where one of the rays originates. If I plug 2 in, I get half of 2, which is 1. Now to figure out what it looks like on the graph, where it has the or equal to, that is going to be a closed circle. So if you go on your graph and you graph 2, negative 3, you are going to have a closed circle there. If you graph the lower one, 2, 1, that, because there is no equal to, that's going to be an open circle. You will never have a closed circle on top of another closed circle, as far as like one up above and one below, because that would not be a function. You may have a situation where one of the pieces stops the same place the other one starts, and then you just have one filled-in circle. You don't have to write multiple circles. Now we know where the rays stop and start, we need to show the direction. So what I'm going to do is now pick a point that is less than 2 and put it into this bottom equation. That gives me the direction that that ray heads. You can use your calculator. You can also pull up a table, and you can look at a table and see the different values. I'm going to make it easy since I am going to do it in my head. I'm going to pick 0. 0 is obviously less than 2, and it's really easy to plug in. When I put 0 in here, I get 1. What that tells me is it tells me the direction of the ray. It tells me that it starts at 2, negative 3, where you put the closed circle, and then if you graph 0, 1, and you'd connect those and draw a ray, that's the ray that's heading to the left. It's the less than side, which will always be the ray heading left. So there's one piece of my piecewise function. The other piece of the piecewise function starts at your open circle, 2, 1. We need another point. So I'm going to pick, you could pick any point. Notice that I have to take whatever number I pick and I multiply it by half. So I'm going to make it easy on myself and I'm going to pick 4. Because 4 is something I can easily have. I can take half of 4 and I get 2. So now if I graph this point, 4, 2, that tells me the direction this ray goes. So here is my piecewise function. Again, they look very disjointed because they completely change the way they're defined at 2. So before 2, you have a line has negative slope, it's dropping, and then after 2, we have a line has a positive slope, a more gradual slope. I want to do one more for extra practice, and this is as complicated as it can get whenever it has 3 different functions. You're still doing the same thing. You're doing a series of points. You want to know where each piece starts and stops. The difference is going to be the middle piece, so I'll make sure I explain that in detail. We're going to start with the top equation. We want to know where does it originate. We want to put negative 1 into this equation. So if I put negative 1 into this equation, negative 1 plus 3 is 2. I'm also going to put negative 1 into the second equation. Second equation is saying where do we start back up again at negative 1. So if I put negative 1 into the second equation, and again, you can do some work off to the side. You can use a table on your calculator. You get 2 minus 1, which is 1. I'm going to, instead of going to the third one now, I'm going to go back and just comparing the first and second one. So I know where the first one and the second one kind of start and stop. I need to have another point to give me the direction. First, let's do open and closed circles. For the negative 1, 2, that is going to be an open circle because it is just a less than. It doesn't have an equal to. For the negative 1, 1, that one is going to be closed because it has the or equal to. Now I need to pick a point that is less than negative 1 to put in the top line because I know this open circle is one of the endpoints, but I don't know which direction it's going. So I'm going to pick a point that's less than negative 1, so I'm just going to pick negative 2. And again, plug it into your equation or use your calculator. Negative 2 plus 3 is 1. So that's telling me, negative 2, 1, that this is the direction that ray goes. It started at negative 1, 2. It was an open circle, and then it goes through that second point. That second point is just helping you get that direction, get an idea of how that ray should go. When you have one that looks like this where you have 3 lines, your middle line is not as difficult as you may think. You are just plugging in the beginning and the end x value. Essentially what you have here, you don't have a ray, you have a segment. So you just have to figure out where does the segment start, and you already know that. You plug negative 1 in and you got positive 1. And then where does it finish? So you're going to put 1 in because that's where it stops, that's this value. Put 1 into your original function, so negative 2 times 1 minus 1. I get negative 2 minus 1, which is negative 3. That is also going to be a closed circle, so I'm going to go 1, negative 3. Here is that middle line. It is just a segment. It starts at negative 1, so you have to find the y value, and it ends at positive 1. You have to find the y value. Finally, the last one, it's starting at 1. It will be an open circle. We have to put 1 into it, so if I put 1 in, I get 3 times 1 minus 2, so I get 1. So 1, 1 will be an open circle. And then I have to pick a number bigger than 1 so I get the direction of this ray. So I'm going to pick 2. Keep the numbers small, easy to do in your head, easy to look up on a table. You get 3 times 2 minus 2, which is 6 minus 2, which is 4. So 2, 4 on your graph. So this is what your piecewise functions will look like when you have 3 different equations. You're going to have a ray heading left, you're going to have a ray heading right, and then in between you're going to have a segment that is just going to have a definite starting and stopping point, whereas the other ones have one endpoint, which may be open or closed. In this case they're open, and then extend the other direction, which is what a ray is. This is as big as we'll get in the piecewise. You can look at ones that are larger. I will not ask you on a test or quiz to go through like a piecewise function of 4 or 5 equations. The process is the same, but we're going to stick with ones that are 2 or 3 equations, and hopefully these examples help.